in this section, we're putting together everything we've learned so far. So we have finding the x and y-intercept, finding asymptotes, finding intervals of increase and decrease, finding max and min, finding concavity, and putting all that together and graphing. So here's our first one. So we're just going to go through the steps here. Your guidelines were on the previous slide. The first thing we need to do is find the domain. So to find the domain, we set the denominator equal to 0. So my domain would be negative infinity to negative 3, union negative 3 to 3, union 3 to infinity. Okay, so that's your first step. The second step is to find the x-intercept. So it tells you to find the x-intercept, let y be 0. So that's your function value. So 0 would equal 2x squared minus 8 over x squared minus 9. So I can multiply both sides by x squared minus 9. So they cancel out on the right, leaving me with 2x squared minus 8. And anything times 0, of course, would just be 0. So solving this one down, let's see, I could do it by factoring, or I could also do it by the square root property. I'm going to choose factoring. Okay, I'll divide both sides by 2 to get rid of it. So 0 would equal x squared minus 4. That's the difference of squares. So x plus 2 would equal 0, and x minus 2 would equal 0. So I would have that x equals 2, and x equals negative 2. Okay, right there you definitely could have put that as you could have used the square root property there as well. Remember that when these are the x-intercepts, which means that y is 0. So that means you would have a point at 2, 0, when x is 2, y is 0, and you would also have a point at negative 2, 0. So that's what we would get for that piece. The next thing that you have is your y-intercept. To find the y-intercept, you're going to let x be 0. So remember that f of x is the same thing as y. Remember for this one, everywhere you see an x, you're going to put 0. So that's 2 times 0 squared minus 8, 0 squared minus 9. So that would be negative 8 over negative 9, which is a positive 8/9. Now remember, this is when x is 0. So when x is 0, you had the point 0, 8/9. Keep going down our list. The next thing you have is your vertical asymptote. Okay, remember to find the vertical asymptote, you factor completely. Cross out. And set denominator equal to 0. Okay, so at the top of this function, you can factor out a 2. That's the difference of squares on the top and the difference of squares on the bottom. So we factored. That's what it looks like in its factored form. The second step is to cross out. Well, nothing crosses out. And the third step is to set your denominator to 0. Just your denominator. So we would get that x would equal a negative 3, and we would get that x would equal a positive 3. Those are our vertical asymptotes. Okay, Okay, moving on along. Next we have horizontal asymptotes. The way that you find your horizontal asymptotes is you have three rules. If your highest power is on the top, you do this. If your highest power is on the bottom, you do this. If the powers are the same, you do this. Those horizontal asymptote rules can be found on a previous slide in this note set. So if I look at my function here, I see that the powers are the same. Okay, so the rule says when the powers are the same, you take the coefficients. In this bottom x squared, there's an understood 1 there. So remember, a horizontal asymptote is a y equals equation. It would be y equals 2 over 1. I'm going to change it back to orange, sorry. So we're going to have that as y equals 2. So that's how we start those, just going through the list with those. So then we move to increasing, decreasing, max, and min, and so forth. Now I had to put that on a separate slide. So when we're telling about finding increasing and decreasing, the first thing you have to do is take the derivative. Now, I did this ahead of time. At this point, I'm expecting you to be able to do this. So if you had trouble with finding the derivative, please message me. I'll be glad to help. But just letting you know, to find the derivative here, you're using the quotient rule, low d high minus high d low over low squared, and this is what we get. Now, to find intervals of increasing and decreasing, once you get your derivative, you're going to set your derivative equal to 0, and you're going to see where your derivative is undefined. Okay, the derivative equals 0 when the numerator equals 0. The derivative is undefined when the denominator equals 0. So let's solve out these. Take the square root of both sides. So these are, they're not all my critical numbers, but they're definitely numbers that we are going to put on our number line. Okay, this is our number line for our first derivative. Now remember, when you're putting these numbers on the number line, the first thing I have to do is look back at my domain from the previous slide. I know that -3 is not in my domain. I also know that +3 is not in my domain. So these are not critical numbers because they are not numbers that are in the domain. So you'll also notice that we found those when we were seeing where the derivative was undefined. We also need to put the number 0 on this number line. Okay, so let's pick some test points. I might choose -4. I might choose -1. I might choose +1. And I might choose 4. Now remember, you're plugging these into the derivative, and I wrote the derivative on the far side. Let me show you something else a little neat. If you look at that denominator, it's squared. Remember, squared numbers are always positive. So all I really have to look over is the top part. If I plug -4 into this expression, I get -20 times -4. Here again is where I'm plugging it in. And I'm putting that over something squared. Now, you don't have to do the something squared because you know that anytime you have something squared, that's a positive. So the denominator is going to be positive. -20 times -4 would also be positive. So this is a positive interval. Okay, let's try -1. If you plug in -1, you get -20 times -1 over a positive result. Because remember, even if you put in a -1, you get something squared, and something squared would be positive. So this gives you a positive 20 over a positive 1, so this part is also positive. Okay, then we can plug in 1. When I plug in 1, I get -20 times 1. My denominator is always positive since it's squared here. So that's a -20 over a positive. So a negative divided by a positive would give me a negative result. Okay, looking at the last one, that's the number 4. So you could say -20 times 4 over something squared. So that's a -80 over a positive result. And a negative divided by a positive would be a negative result. Okay, so now let's see what happens. In this first interval, I'm increasing, and then I'm increasing again, and then I'm decreasing, and then I'm decreasing again. So my intervals where I'm increasing are -infinity to -4, and, I'm sorry, that's incorrect. You don't put your test points in there. You put your what I call my walls. These are the values we're using. So it increases from -infinity to -3. It also increases on this middle interval, so that would be from -3 to 0. It decreases from 0 to +3, and it decreases again from 3 to infinity. Now remember, you have a local max or min where there's a change. So we went positive to positive, so there was no change there. I went positive to negative, so that was a change, and that's a max. So I have a local max at 0. There are no local mins. Now, while we're there, we have to find the y value. So remember, to find the y value, plug into the original. Not into the derivative that you see on this screen, but into the original function that was on the far side. Just to save us some time, that original function was 2x squared minus 8 over x squared minus 9. So if you plug 0 into that red function at the bottom of the screen, you get 0 minus 8, 0 minus 9. So you get -8 over -9, which would be a positive 8/9. Okay, continuing this problem, you have to tell if it crosses the horizontal asymptote, and here's how you do that. Your beginning function was 2x squared minus 8 over x squared minus 9, and when you calculated the horizontal asymptote, it was 2. So you set your function value equal to your horizontal asymptote value, and you see if you can solve it. So if I'm solving out this equation, I'm going to multiply both sides by x squared minus 9. My x squared minus 9's cancel out. So that leaves me with 2x squared minus 8 equals 2x squared minus 18. So I need to get my x's on the same side. Well, when I do that, these x's cross out, and I get -8 equals -18. That is not true. So my x's canceled out, and it gave me a false statement. So since it gave me a false statement, that means there was no solution. So to answer the question, does this graph cross the horizontal asymptote? No, it does not cross. So it's not going to cross that asymptote. Okay, we had our intervals of increasing and decreasing here and our local max. I put all of that on our graph, and now we're ready to graph it, to put it all together. Okay, so let's label what we know. I know that at, let's see, x equals -3, I have a vertical asymptote. I know at x equals +3, I have a vertical asymptote. And I know at y equals 2, I have a horizontal asymptote. And I also know at this point that it does not cross. Okay, let's see what else we have. I have an x-intercept at 2, 0, and I have an x-intercept at negative 2, 0. And I have a y-intercept at 0, 8 ninths, which I'm going to estimate right there. Now, that looks great, but I don't know what happens on this part of the graph or this part of the graph. So sometimes you have to pick additional points to see what's happening. Now, you'll say, well, what do I pick? You can pick anything you want in that interval. So I chose, let's see, what did I choose? I chose negative 4 because I had negative 1, negative 2, negative 3, negative 4. So I just plugged in the point negative 4 and I looked for the y value, and I also tried the point positive 4 and looked for the y value. Remember, to find the y value, plug into the original. So if you plugged negative 4 into the function at the top, you get 3.4, and if you plugged 4 into the function at the top, you get 3.4. Okay, so let me put those on the graph. So I have negative 4, 3.4. That would be 1, 2, somewhere right in here. And I have 4, 1, 2, 3, 4, 3.4, somewhere right in here. Now, those are all of our facts. We have to draw the graph based upon this, and what we're going to use is increasing and decreasing. Remember, it cannot cross a light blue line, and it cannot cross an orange line either. It cannot cross them. So, let's look at the increasing, decreasing part. My graph is increasing from negative infinity to negative 3. So for this interval right here, it's increasing. So that means it's going to be going up. It is also increasing from negative 3, here's negative 3 right here, to 0. So it's going to be hugging that asymptote all the way to 0. At 0, it flips and goes back down. At 3, the graph starts decreasing. So if it's decreasing, that means it has to start high and go low. And that's what your graph would look like.